All right, so I'm going to turn it over to you, Corey, and you can introduce the data from 2020.
Okay, yay. I get to share my screen now. I hope. Okay, does this look like a PowerPoint slide to everyone? Fantastic. Okay, so as I said before, I'm Corey. I am a PhD student in Becky's lab at UT, and I started last fall. So I've been like on some of these workshops, but I haven't like officially, I think, been involved until today. I've been playing with the mosquito data that you all have collected, and I'm going to kind of give an overview, some more big picture stuff that's interesting to us. So I'll just get into it. I don't want to spend much time recapping 2020, but it was a weird year for everything, and that includes, I think, for megabytes. So March was sad face, and then March sad face led to you all returning. Yay, happy face. The 2019 cohort's back, which I don't think was the original plan. So we ended up going virtual, and then we still somehow you all set overtraps and participated in this, which was awesome. From August to October, I'm very glad that you all were able to do that and agreed to do so. So from then, after you all kind of passed those eggs back to us, though, we spent a few months hatching them out. It took a while. We started doing that in November and finally got them all done in January. If you guys hear a dog, it's because it's a dog in my house. So in January, we got done hatching all those. And since then, up till now, I've been working to identify all those adults. And I'm starting the lacrosse screening right now. So I don't have the lacrosse screening data because I had to get all the adults I identified first. But I'm getting into that stuff like now on the timeline. So 2020 was different than 2019 in terms of the mosquito experiment. As you all probably remember, in 2019, it was 10 cups for 10 weeks at each school. The egg papers were held in envelopes like they were this year until the study was complete. And at the same time, UT students, not me, were setting up one cup at around 30 sites within Knox County to kind of provide a comparison data set to what the schools collected. In 2020, it was 6 cups for 6 weeks, so a shortened period with a fewer cups. We still had the envelopes, but this time I had sent an email about how some of my eggs were drying out. And so some of you started keeping your envelopes in plastic containers, sometimes having like moist paper towels or something, and others kept them in open air. This time I set 3 cups at a similar number of sites, mostly the same sites. And kind of big picture questions for me and for just kind of megabytes in general is how does the data that you and your students collected compare to the data that was collected by students in the UT laboratory? And just really quickly, I'll say that doing all these collections can be a lot of work. I collected about the same number of egg papers every week that you all did in total. So it was 96 cups that I was servicing every week. And it would take me about 15 hours to do that. And I sampled like a good amount of Knox County, but not even all of it. There's like still, I could go further west and be laying cups, but I didn't have enough time. It's a really kind of cumbersome, time-consuming process to do all that. And you all, as a whole, collected the same number of egg papers, and hopefully none of you spent close to 15 hours a week doing that. And so it's very cool from a sort of mosquito surveillance standpoint of just seeing what's going on with mosquitoes out there and are there viruses active in the mosquitoes. It's cool to have something like megabytes where hopefully we can offer something beneficial to you and your students, but then you all in the process collect this data that I couldn't collect on my own, especially from as wide of a geographic range as you all did. But the question is, how does this data that you all were collecting compare to data collected by an entomology lab, assuming that in the entomology lab, we're good at it. And I don't know if that's true, but the idea is that I'm good at it. And so if the data that you all collected is similar to what was being collected by this lab, then it kind of gives a proof of concept that we can use to prove the value of megabytes from a mosquito surveillance standpoint by showing that even though you all and your students didn't know about mosquito collections probably before this, that the data you collected is still of real value. And so I'm going to show some of the graphs and statistics that we can look at to try to answer that question. So how does the egg data collected by teachers and students compare to that of an entomology lab? This is eggs just from the schools between the 2 years. So this isn't really comparing UT and me. This is just comparing your egg collections from 2019 and 2020, just to see what the differences were. So in 2019, more eggs were collected by the schools, but recall that it was more cups and more weeks that were involved in this. If you actually look at the average number of eggs on each paper, there were a lot more in 2020. I don't know why. Perhaps you all have ideas of that. Maybe you set cups in places that seem to attract more mosquitoes. But we got more eggs per paper in 2020, and the maximum number of eggs on a paper also was higher in 2020. So that's kind of interesting. And you can also see these weekly graphs showing the average number of eggs per week. And you see more of a trend, like a climb up from week 35 to 37, where it peaked and then kind of dropping back down as we ended the week. But in 2019, the school data was kind of flatter throughout that entire 10-week period. So this is a graph that's showing the UT data compared to the megabyte school data in 2019. So what you're seeing saying cemeteries and parks, the students at UT were setting ovitraps at cemeteries and parks in the same time period that you all were setting your data setting your cups in 2019. And when you do the kind of statistical modeling on this, there's a significant difference between the UT collections at cemeteries and parks compared to the schools. And what that means is that based on the stats, you can tell that the schools collected in general fewer eggs than what was collected by the UT students. And that's not necessarily a bad thing, because trapping at a cemetery versus trapping at a school, they don't have to have the same number of eggs. So this is not a foolproof comparison, but you can see that like the trends are different. But if you remember, the UT students only set 1 cup per site, and you all were setting 10 at each school. So it changes a little bit if you use only the quote unquote best school cups, which is the top 3 cups in terms of how many eggs were collected every week. And that lifts that number of eggs being collected by the schools, so that when you do the statistics on it, it's no longer coming out as like a significantly different thing where the schools were collecting way fewer eggs. But you can see the trend is still not exactly the same. But to be fair, the trend's not that similar between the cemeteries and the parks here either. But there are some flaws with this. The 1 trap per site set by those UT students every week, that creates a lot of room for variability. It's really nicer to set more cups at a site each week, because you can account for differences in kind of cup placement, because some places, even at like the same park, if you set your cup in different areas, you might collect different numbers of mosquitoes. But anyway, I can move on and show this same sort of thing from 2020. And here again, I'm showing cemeteries, this time also houses and parks. Those are where I trapped: cemeteries, houses, and parks. And then the megabyte school data is the average number of eggs collected each week by all of you or your students. So this is with all of those cups included, again, all 6 for you and including all 3 for me. And you can see, I think, a noticeable difference. First, the trend being shown every week in that megabyte school picture, it has that kind of up and down thing. And that's really similar to what was in my data with the cemeteries and the parks. So that's pretty cool, because we're seeing a similar trend in mosquito abundance weekly. And if we, again, consider the quote unquote best cups, the top 3 cups from the schools, that megabyte school portion of this graph gets super similar to the parks and the cemeteries, which is where I collected. And I don't know if that gets other people excited, but it makes me very excited, because the data collected by you all and your students is like, if we didn't have any of my data at all, we could look at yours and we would have an accurate representation of what the mosquito trend was kind of week by week. That the trend was more mosquitoes every week until 37, and then it started dropping off towards the end of the year by week 40. So that's really cool, because we did this thing where hopefully you all learned stuff about mosquitoes and GIS, and hopefully that transferred onto your students and they had a good experience, and maybe lacrosse awareness was raised. But then, like, even added bonus is that we got really valuable mosquito data. So like I said before, doing this mosquito surveillance stuff is expensive and difficult. It's really time consuming. And a lot of times people try to do these citizen science projects to deal with that because they don't have money to hire a bunch of people like me to go do a ton of mosquito trapping. And so they hire volunteers instead. And the projects for that are cool, but usually they don't end up being sustainable because people don't have time or interest to volunteer all their days to doing mosquito egg paper stuff. So Megabytes has hopefully value in a lot of different ways as this interdisciplinary collaboration between the university and you all as the educators. And it does these things that I've talked about, training educators and having high impact learning experience for your students. And importantly, giving just a heightened awareness of lacrosse encephalitis. But the cool thing to me as an entomologist is that the data that you collect during this process is also, I think we can now show that there's going to be usefulness to this in the long term for using the data collected by students and teachers to do science stuff, try to prevent lacrosse encephalitis in East Tennessee. So now we have the evidence that we can use to move forward with this project on the egg data side. I've also done some stuff with the adult data, who hatched and how many. I'm still working on mine, identifying my adults. It's been a very slow process to identify all the adults that we got, but I was able to identify all the school ones. So we've got that data. So from here on, it's only going to be school stuff. So comparing, in 2019, only one species emerged out of the egg papers that you all collected. And in 2020, we doubled the number to 2. We got another species, which was very exciting for us. In 2019, we had about 1,000 adults come out of 95,000 eggs, which isn't a great rate of getting adults from those eggs. But in 2020, we got a lot more adults, like almost 9 times as many, maybe more than that, out of even fewer eggs. So that's cool. We got more adults this year. On average, for per egg paper, we were getting about 1 adult in 2019, and that went up to about 20 adults in 2020. So that's also good news. In 2019, we had at most 332 adults coming out of 1 egg paper versus 2020, where it was 449. And the average egg to adult percentage is what I'll call it here. In terms of each paper, what was the average number of eggs that became an adult was 3%. In 2019, that's by averaging the number of eggs we had, or not averaging, by dividing the number of eggs we had over the number of adults that were coming out from each egg paper. That went up by a lot in 2020 to 14%. And we can talk about some reasons why that might have happened in a moment. But here's a trend, a weekly trend for the 2 species of adults that we were getting out of the egg papers. The trend follows pretty similarly to the egg trend, which is good. Week by week. So you can see we got a lot more Aedes albopictus in red. That's the color that, or the dots that are higher up each week. Those are your albopictus. But the trend was still similar for Triceriatus week to week. So, but we can see that at least our number of adults was showing that same trend as the eggs in general, which is good from a data standpoint. I mentioned before that I emailed about how my eggs were drying out. And so I had started to keep my egg papers, the envelopes, in plastic containers with something to keep them humid, because I thought that it was an effect of low humidity that was causing the eggs to dry out. And I knew just from previous experience that when they dry out like that, it's hard to get them to hatch out, if it's even possible to get them to hatch so that you can raise them to adulthood. And after I sent that email, some of you started to do the same thing by trying to hold your envelopes in plastic containers. And I'll just say, keeping the envelopes in like open air, that was what you were instructed to do. So there's nothing wrong if you didn't do that. But some of you responded and started to put them in plastic. Actually, about 7 is what I am aware of, which is about half of you. So from just a little experiment to see what works better for hatching, it worked out really well that we have about half and half. So from weeks 37 to 40, we can compare those of you that had your eggs in some sort of a plastic and those of you that kept the envelopes just sort of in the open air. And there were significantly more adults that came out for those of you that had the envelopes in plastic. And here I've graphed that with a box plot. So if you look at the really thick lines in the box plot, so those are the median numbers, like 50% of the value is at the median. So what this graph is showing is the average percent hatch, or like the average percentage of eggs that resulted in an adult. For those that were stored in the open air, not in plastic, about 1,000, about almost 1,500 adults came from 32,000 eggs. And you can see there were some Aedes triceriatus, and then a lot more Aedes albopictus. And for those stored in the plastic, it was like almost 7 times as many adults that came out, a bunch more Aedes triceriatus and a bunch of Aedes albopictus. And so very clearly there was an effect here. And this is not really something that you all could have known because you were taking our instructions, but it's useful from our end for future years of this, because we can start to consider that maybe just putting them in plastic is a good way to increase the hatch rate. But also, even among the people that put them in plastic, there were different viabilities in terms of how dry were the eggs when we received them. So maybe we can talk to some of you and figure out what exactly worked the best. Also, during all of this, educators and students came up with questions. And so your trap placement was sometimes based on a question that you were asking internally. And you can work on answering some of those questions moving forward today as we learn about data analysis. But I can highlight a couple of cool ones to hopefully get us excited. One of them was from Jefferson Middle School. They asked if cups in trees near human activity collected more eggs. And so I graphed that, the average number of eggs being collected in each week. And they did find a difference where there were significantly more eggs collected in traps that were placed near human activity. I don't remember exactly how they defined that. I think that it was like closer to sports fields and stuff like that, but I'm sure that Julie knows. So, but this was interesting because they found, when I do the statistics on this too, not just making a graph, the difference was significant between the traps that were far away from human activity, whereas the ones nearer to human activity collected more eggs. Here a question was, does elevation change egg laying behavior, from Seymour Humphrey High School? And they placed some traps at a higher elevation and some at a lower elevation. I'm not sure exactly how different those elevations were, but they found a significant difference where more mosquitoes were laying eggs at the lower elevation, which is pretty interesting. I don't have a good hypothesis for exactly why that occurred, but they definitely found a difference that you can see on this graph. But they weren't the only ones that asked that question. At Saudi Daisy High School in Chattanooga, they asked the same question, and they found more eggs at a higher elevation than at a lower elevation. So the exact opposite result with a similar question. So that's interesting. I don't know why that happened, but it's kind of exciting, and it's something maybe to consider looking at. But I won't keep going through all of those so that we can have fun looking at all of your questions later on. And so now I've got fake awards. These are awards for like who collected the most things or got the most eggs or whatever. But in a way, perhaps getting fewer mosquito eggs could be considered a victory, depending on if you don't want to have a lot of mosquitoes around you. So you can interpret this how you will. So who had the most eggs on a single egg paper that was returned? By my count, it was the Seymour High School group with Christy Ridley had a paper that had 1,181 mosquito eggs laid on it. So that was a fun count. And they had some runners up from Jefferson Middle School and PHSM. I can't remember. That's Powell High School, I think. They had the most adults that emerged from a single paper. I don't know if it was the same paper, but the same school won this one. So perhaps it was the same paper with 449 adults coming out from an egg paper at Seymour High School. And then at the runners up being Jefferson Middle School and Bearden Middle School. Most eggs overall, same. Congratulations to Seymour with almost 10,000 eggs. And then runners up were actually quite a bit lower than that, about 2,000 eggs fewer coming from Seymour and Jefferson Middle School. But the story changed with the most adults overall. That came from Jefferson Middle School, interestingly. So almost a little more than 2,000 fewer eggs for them, but they actually had the most adults emerging out of them. So something was effective in the way that you held your eggs, Julie. I don't know what you did, but it was pretty good. The most Aedes triceriatus, though, out of nowhere comes Saudi Daisy High School with 1,000. And if you look right above, Saudi Daisy High School had about 1,600 adults, and almost all of those, 1,000 of them, were Aedes triceriatus, which as a species we got 0 of in 2019. So personally, I'm very happy with this. Very excited to understand why that happened too. Why no tris last year and so many this year. And the runners up aren't even close on that. Seymour High School had so many eggs and so many adults, but so many of them were not triceriatus. So that's pretty interesting. Most Aedes albopictus, that comes from Jefferson Middle School. And the best like egg to adult percentage also comes from Jefferson Middle School. 44% of your eggs resulted in adults for us. And if you remember, the overall percentage was like 19%. So Jefferson Middle School, amazing, amazing egg holding quality. Okay, so if there's like questions or commentary, I can take them, but kind of like Becky said, thank you. Teachers, I'm just a graduate student. I'm not a teacher. I can't imagine how ridiculous the last year has been. I think it's amazing that you all participated in Megabytes again, because I feel like what you have been asked to do in the last year or more is just ridiculous. It's like unfair. There's like a few professions that have been asked to do such a crazy thing, and you all are among them. So thank you for doing just what you do, but thanks even more for somehow doing Megabytes. I'm very excited that you did it because we have all this data to do stuff with. That's the end of my slideshow.
Thanks, Corey. I love the data set this year. I mean, I loved last year's data set, but like we got triceriatus and we have improvement and like things are going up, right? 2021 is going to get better in 2020 and all of that. Do you guys have questions? I know in the chat there were a lot of things kind of blowing up on my end. I'm gonna just take a moment and see if you all need a moment to digest what he just shared, or if you have ideas, or if Julie wants to give a seminar on how to collect and can trap mosquito eggs.
Yeah, I did not see these chats as I was going, so if I should have been stopping for them.
No, you're fine.
I didn't stop.
I'm just going to make a comment about elevation. It's in Chattanooga, because we had the yellow fever epidemics. It's why all the rich people live on the mountains now. During the epidemics, if you had money, they basically made summer towns up on the mountains, and the only reason they live year round, they now figure out how to heat them. But back then, everybody moved up on the mountains to get away from the yellow fever because nobody was dying up there. So apparently elevation does have some kind of influence on how high up far the mosquitoes can go.
Elevation definitely plays into where mosquitoes lay their eggs. I know some studies that have been done in Iquitos, Peru, and basically when it gets too cold, when it's too high, mosquitoes aren't going to be laying their eggs there. I think it's pretty awesome that we could potentially get elevation for every single one of these ovitraps, right? Because we have a GPS coordinate and we can do some comparisons by elevation or something else if you wanted. One reason why we wanted to get everybody's questions though was so that we could look at this and then maybe share questions and answers with one another too. You know, you can make your data set bigger, not just have your own 6 traps worth of questions, but bigger, if that makes sense.
We ran actually 2 elevation questions. One was, were there more mosquitoes on the ground or 8 feet up in the tree? And then we also had the school at 1 elevation, then 3 sets of traps with the school elevation, then 3 were down in the valley, which is a good distance below us. So I'm going to look to see where all the mosquitoes showed up from.
Yeah. So Diane, your question on who was the opposite, who did the elevation? It was David. Or I guess that side. David's over there for me. I'm going to keep scrolling through the chat real quick. There is a request for Julie to share her egg collection and storage procedures.
That'll take a bit. I'll have to remember. It's been a while, so I'll have to collect back. I'll get back. I'll write a paper on it.
Perfect.
In my spare time.
Right. Yeah. Go through real quick. Yeah, I'll leave that.
I do remember my classroom is quite moist because we're doing relative humidity and humidity with our weather data collection. And I have a pretty moist room, so maybe that's a factor.
That's interesting.
And it stays about 69 degrees. It's freezing, even pretty much year round. So perhaps it's just the climate in my room, not the expertise of my collections.
Let's see. I'm failing to go through the chat. So if anybody else has a question they just want to say out loud, we can either keep going and turn it over to Josh or take a small break. I propose we kind of keep going though. I have about thumbs up for a break, 5-minute break, or like the high five reaction if you just want to keep rolling it over to Josh. All right, we're going. Josh, you're up. I'm gonna stop recording.
Can you all hear me okay?
Mhm.
Cool. Good morning, everybody. Thanks, Corey. That was a great presentation. So, as Becky said, we have sort of a choose your own adventure today with 3 different ways to analyze the data. And so the first way that I'll introduce will be using CODAP. And a lot of data, but especially the data that you've collected, has a lot of different layers to it. One of them is the spatial layer. So a map might be the best way to represent the data. But there might be other questions for which data that you would store in a more kind of spreadsheet format might be the way that you find most useful. So CODAP is not very well suited to analyzing spatial data, the kind that ArcGIS is quite good at analyzing, but it's quite good at analyzing kind of row column data. My kind of plan today is to kind of remind us a little bit about what our data looks like in CODAP and some of the things we can do with it. And just to set the stage with some questions for you all for things that you could possibly talk with each other and with me about later this afternoon if you wanted to plan a lesson for your students to use CODAP to analyze their data. I guess on that note, how many of you used CODAP? It's okay if the answer is no one, truly. How many of you used CODAP last year with your students in a class? Because we used it in a workshop, but that doesn't mean you used it with any students. I see Christy. Thanks, Christy, for letting me know. Did anyone else that doesn't have their video on, did anyone else use it or consider using it even? Emily, okay, cool. I thought so, Emily. I remember seeing something on Twitter about it. And Lauren, okay, great. So, I mean, if a few of you this next year use CODAP, that's great. Paula says mine aren't ready for it. Yeah, I understand. That's totally understandable too. And so I guess some things you could take away from today, even if you don't plan to use it or even want to use it, could be some strategies that could be useful if you used Google Sheets or Excel with your students too, or just even more general ideas about some things you can explore using this data set. That said, it would be even better from my perspective if you came away from the next 30 minutes or so. Is that the amount of time, Becky? Do I have 30 minutes total? Okay, let's say 25 minutes. 25 minutes or so with some ideas for how you could use CODAP. Okay, any questions before we dive in? Okay. All right, can you all see like a spreadsheet here in my screen in CODAP? Sort of? Huh.
Seeing black.
Yeah, it's a black screen.
That's not what I intended. Okay, let's try this again.
Yeah. It looks like it was trying to, but not there yet.
All right, take 2. Same thing, still just a black screen? Blank screen, black screen.
Yeah, we see your cursor, but not CODAP.
How strange, because the windows are obviously appearing on my screen. I'll try sharing just that tab, then that might, or just that, yeah, just that tab of the browser.
Emily,
thanks, Michael.
Yeah.
Emily, I'm sorry, do you have a question, Emily? Thanks, Michael. I think that might have been Emily nominating, indicating that she had used CODAP this last year.
Yeah.
Sorry, I'm the bad student who forgot to lower her hand.
Oh, not bad at all. It's okay. Okay, can you see a screen now? No. Oh, how frustrating. All right. What do we do when we have tech issues as teachers? We need to maintain calm. Take a deep breath. Okay, I'm gonna try. I do have another computer, which would take me about 2 to 3 minutes to get, I think, all situated on. So I'm gonna try. All right, the old trick. Log out and log back in. I'll try that. Okay, I'll be 1 second and then.
All right. Well, let's use this moment then to take a 5-minute biological break if one needs it. Okay. Awesome. All right, Corey, I'm making notes of the questions that we need to follow up on.
All right. Any luck or still just a blank screen?
Right now, still just a blank screen. I did
How
send everybody away for a bio break.
Oh, a bio break. Okay, that helps. Great. So I'm going to switch
Yeah.
over to my desktop. I have no idea why it's doing this. It's obviously worked just yesterday.
Saturday, you know. Yeah.
Yeah,
Corey, that was a great
it's all
presentation.
blank for me.
Still blank. Okay, I've got my desktop
Here,
here.
maybe I'm sure it'll be fine. Hey, just a quick question. I can do this, or we can tackle as a team.
I can try
Michael-
sharing.
Okay, thanks. Michael, you sent back a revised code book with the variables. Thank you. Could we share that? No, that's not my question. What's the best way to share it? Could we share it as a link to a Google Drive doc, just somewhere where teachers can really easily access this?
It's actually in the layer description in ArcGIS Online, but I can also put it there. So I can.
Oh, no, brilliant.
I was trying to think smarter, not harder this time. I think I failed most of it, but occasionally I got it right.
No, it's brilliant. So it's in the ArcGIS story map.
Hold on, let me get you pulled up.
Okay, thanks. Sorry for the sharing issues. Yeah,
Dude, it's not you.
thanks. Thanks. Yeah, this data is super cool. Corey, your presentation reminded me of that, and then looking through the data this morning, preparing for this next segment, did too. There's like a world of questions that you could investigate with it from an educational perspective and maybe a scientific one too. And so Corey and Becky, will we merge like the data that you collected with this data at some point? I mean, I guess it's already merged for some of these analyses you ran, Corey. Because like right now the data in the CODAP is just the school-based site collection.
Yeah, I think so.
Okay, cool.
Yeah, right now it's just school because it's much easier that way. And he's still IDing all the adults that he collected.
Yeah.
That week 37, once he gets past that hump, it should be smooth sailing.
I see the wisdom of saying that something will be easy. Becky raising caution, or the caution through your because of your wisdom about saying that kind of thing. All right, I think
If there's a chance to screw it up, I can do it.
not the only one. Okay, let's turn off the.
Yeah. And if you want, I might be able to share screen or whatever you have if you want to either drop it in Slack or an email or something, or even in the chat.
All right, anything now?
It's still a black screen, but we can see your
What in-
mouse. I know.
Is that right?
It's very weird.
It's weird. I really need to interact with. I mean, I don't need to, but it's really important for me to be able to interact with CODAP.
Yeah.
How strange. All right, I'm gonna try one more thing. This is on a totally different computer. What in the world could this be? I mean, I've used this for teaching just on Thursday. Both of this laptop and okay, still blank screen.
Oh, we can see your desktop now.
Yay. Okay. Last time is a charm.
So now we can see everything that you're doing about a sandbox. And
Sandbox.
yeah,
Sandbox?
and sandbox.
Weird. Okay. Is everyone back? Sorry if I'm holding everyone up here. I think I am. Michael,
When
do you
you're-
mind? Sorry, Becky, pardon me.
I was gonna say, when you get back, if you can just do a reaction, so I can kind of try to keep track a little bit.
Okay. Michael, do you mind chatting a link to that storyboard, story map in ArcGIS one more time to me?
You want how about either the hub or the dashboard instead, or do you just need?
Yeah. The dashboard would be great because I also need the link to CODAP again. I can open it up in its own tab from there. I checked that this morning. Sorry, I had everything ready over there and then not here. Okay, great. Thanks.
And this will bring you to the hub, perfect. And then if you click 2020 maps and data, that should get you to, scroll down just a little bit.
Sorry, you saw
Joshua.
where I was.
Oh yeah, perfect.
Oh,
okay.
you were pointing me here,
And
I
that should-
think. Yeah. Okay,
Yeah,
this is
'cause
it.
that's
Okay,
also
great.
got the
All right,
dashboard
ready to
stuff.
rock. Thank you. Thanks for putting this all in one place. That's awesome.
Yes. And so everybody in the Zoom room will have access to it also, which is great.
All right, so I'm ready whenever everyone's back.
All right, do one more reaction for me. I like your stuff. That's perfect. Looks good. The other Josh Rosenberg's not reacting, but that's okay. We'll just leave him behind.
That's not the good Josh. This one here. I wouldn't trust.
We'll say that one's Joshua. Yeah.
Yeah.
All right. Thanks to everyone for being patient. But we all know that is what we do now. We're really good at patience.
Okay. Thanks everyone for your patience again. CODAP is a tool for analyzing data. It looks like this. To pull it up like on your own, you can just Google CODAP and you can really quickly get started without logging in. That's probably my favorite feature of it is there's no software to install and there's no login. Just this try CODAP link will take you to a blank document. To upload data, you just drag in a CSV file, and that's kind of the only trick is that if you have this data in an Excel file, you have to go file, you have to in Excel file, save as, and then save as a CSV, and then you can just drag or upload that data here. So that's just what I did. That's what I've done. And then I shared a link to this workspace, basically this data with Michael, who then posted it on the dashboard. I'm sorry, the page. Michael, how do I refer to this precisely?
Yeah, sorry.
The hub.
I'm hitting everybody with new stuff. Yeah, so this is the hub.
Okay. So just so in case you want to follow along right now, although maybe later this afternoon would be a better time to do this, I'm going to chat a link directly to, Michael has a link to the hub. That's the last message in chat right now. And then I'm chatting a link just to this workspace here too. So if you want to see exactly what I'm looking at here, you can click that link. That link to CODAP. Okay, any questions? Because I want to make sure we're all really on the same page here before we go any further at all. Okay, cool. Thanks. Great. Okay, so so this is you can think of it as a spreadsheet, just like in Excel. And an important thing about CODAP is that it's not designed necessarily to be easier than Excel or Sheets, but it's designed to make certain things easier and certain things more, not more challenging, but to require a little bit more thinking and in a way that could be good for understanding your data. So here I can see that there's 576 cases or 576 rows. Case and observation usually refer to the rows in your data, and then the columns, as you well know, refer to the number of the variables in your data set. So scrolling across here, we have a lot of variables. Some of them are kind of immediately probably meaningful and make sense to you, such as school. And then others for really all of us require some additional definition. On that note, Michael posted a data dictionary or a code book with descriptions of all of the codes here. So if you have questions about any of them, you can easily get that. Michael, I see you typing right now, and I'm guessing you're pulling that up or sharing a link to it. But would you, if not, would you be willing to do that?
So there should be in the chat, if you scroll above Joshua's link to CODAP and you scroll above my link to the Data Hub, there should be a PDF that says datadictionary.pdf. I think if you download that, that should have what all the column headings are.
Okay. I think you can see it on my screen right now. Okay, great. So, I mean, it's a pretty complex data set. There's a lot of information here. I'm going to put this over here because I'm probably going to want to refer to it later. Okay, so first things first, something that I find really useful when using CODAP is if you have some kind of hierarchy to your data, to nest the data based on that those groups in it. So there's a lot of ways you could group this data. For instance, you could group it by shade type, or you could group it by week. But something that I think is especially useful, and given how we've collected our data and what we're trying to do with it, is to nest by educator. And to do that, you literally just click on the column. You click on the column educator, and you drag it into this sidebar here of the data frame. So I'm just going to kind of do it all from scratch here. So click on educator and drag it over to this sidebar. And the data will have this kind of visual display of how for Boris, the first 36 cases are all associated with that with you. And similarly, the next 36 are associated with Henke, and so on. And so this can be useful for a number of reasons, as we'll see in the next few minutes. Something that can be useful just for getting a hang of the data is taking a column that's especially important and just trying to make sure it sort of makes sense to us, and that there's not anything totally weird going on with the data, or we have the wrong data, or we're missing data, or something like that. So I might take a look at like total eggs first, just by dragging total eggs into this. Sorry, I want to make sure I'm doing everything from scratch here. So this is a window that you get from clicking graph, and this is like maybe the most important part of CODAP apart from the data itself. So you can click on graph and it will pull up this window. Right now there's nothing in it at all, but if you drag total eggs over into it, it should give us some kind of representation of here, kind of the distribution of total eggs. So it's telling us something like the count. So here we can see that all of these cases in the data are associated with, all of these here are associated with 0 total eggs. And if we click on it, it'll take us to that row in the data where we can see that for this school, this trap code, there were 0 eggs and unsurprisingly 0 adults too. That makes sense. That's kind of like, that gives us some confidence in the data here. This is making sense. Where at the same time, we can click on kind of this one observation over here. There's many cases with 0 adults. There's only one with 1,181 eggs from our mosquito heaven here down in Seymour. And so you can do this just maybe with your students, or you can do this just like I did, just to get a grip on the data. This is sort of making sense to me. Any questions at this point? Okay, so at this point, I can click down here to remove that and just get back to a blank plot. I could also just X out and then create a new one. Something to maybe take a look at could be land cover. So I have to find that here up in my data. Where is it? Okay, here it is. So I'm going to drag that down to the x-axis down here on the bottom. And does anyone have any kind of questions or noticings or wonderings based on just looking at this here? What is this telling us? What does it make you think? Sorry, I can't see all the windows. So if anyone has a question, you can just unmic, or one of the members of the Megabytes team can kind of moderate if that's all right.
They liked trees.
Okay, so David said they like trees. So does anyone have any thoughts on what David said, or do you agree or disagree with David's observation of this plot of the data? I'll add something to it. It won't really change anything meaningfully here. All right. Does anyone does anyone disagree with what David said, that they like trees? Becky, I see a hand here. Yeah. I can see you, and I think I can see you, David, Michael, and that's it in my window now.
So if you all look at the top, it's cases, right? And if each row is an egg paper, it's not necessarily how many eggs, right?
Okay, so Becky introduced a different idea here. So different than what David said, Becky is raising the possibility that this is telling us something fundamentally different.
Okay, we like trees.
Okay, so David, you've refined your comment here. So can you say more? What do you mean by that? You changed the pronoun there, but it changes the meaning of the interpretation of this figure. And I'm curious what you meant by that.
Well, if this is where the egg papers were, we put them there. So apparently we were putting a lot of them into either forest or tree areas, if that's what this data is showing us.
Okay, does anyone have any reactions to what David just said? Anyone different?
Does this look right to people? Were there about 3 by 12 traps placed near parking lots?
Yeah, every time you create a figure, it can be something to communicate a result, but it can also be a way to interrogate your data and make sure that it sort of is representing what you think it is. So yeah, this is a good, as Becky's kind of doing here, kind of a good check on our data. Do we expect cemeteries to only make up 2% of the sites if what David interpreted this to mean is indeed what this is representing? Or do we think that we actually had a lot of sites, for instance, in field grass? In fact, more sites in field grass than forest, woodland, and tree line. So something we can do that you can do with your students too is it's often easier to interpret this kind of figure when there's some kind of order to it. So you can just drag these along the x-axis here in a way that helps you to sort of understand really clearly what the kind of rank order in these is. These two, I think they are precisely the same number. We can change percent to count, and that should make that clearer. Yeah, precisely. Wow, that's interesting. I guess that's the thing of, never mind, sorry. I was going to quote Ted Lasso. Has anyone watching that movie, that show? It's just watching last night. So the thing about coincidences is they sometimes happen. So yeah, I guess it just so happens that there's precisely 204 cases associated with each of these two types, these two different, sorry, land covers. So, okay. So this might be, sort of helpful just for checking our data, but to begin to understand maybe a little bit more about what other things might matter, something that came up, Diane, you mentioned this in the chat. We might want to look at another variable just to get a sense of, again, not even our 80s yet, if again, what David mentioned here is true, this is where we like to place traps, but rather, but just to gain kind of more insight into what these traps are like. So we can add another variable. Sorry, I did that kind of quickly, but actually, I'll do it again if you don't mind. Sorry, I don't mean to be too slow, but I also want to walk through it. So right now we just have land cover on the x-axis. We just see a count of the number of traps, number of cases associated with traps in these different, associated with these different kinds of land cover. So we could take water adjacency and drag it to the y-axis. And we get a different plot that represents sort of the tabulation of water adjacency by land cover. So does anyone notice anything here or wonder anything based on this? And just to add one more question to that, does this give anyone any ideas about sort of where there might be more or less 80s? So starting to go from where we place the traps and where the observations are to where 80s might be? I wish I could see everybody so I could call on somebody. All right, oh, there we go. I've got my window bigger here. Would anyone be willing to share anything that you're noticing or wondering here, even if it's there's not much going on here. This figure isn't quite what we were hoping to learn about yet.
So Josh, they're having a hard time seeing the graph. If you can make it a little bit bigger on your screen, I think that would help.
Thank you. Sorry about that.
In fairness, you all can see I'm doing a manual Zoom, right? Like
Sorry, I didn't realize that it was hard to see. I still see I still see
No,
some
that's
people
better.
some doing
That's
manual
better for
Zooms.
me.
Okay.
Yeah. So one thing that I can point out is that there's a number in the top right corner of each one of those boxes. Like there's 0 traps that were placed adjacent to water in a cemetery. So all 12 traps in the cemetery were not adjacent to water.
Okay, so Becky noticed something about the cemeteries and how they're not adjacent to water. Okay.
Yeah. And there's a
building
total count
yeah.
in those, which is nice. You don't have to count all the little dots.
Yeah. Yeah, that would be a little laborious here for the forest woodland, not adjacent sites. Someone else, if you can see. Still having a hard time seeing? Yeah, I'm sorry. Okay, I won't belabor the point then, but one thing I noticed is that, yeah, thank you. Oh, sorry,
Okay,
was that?
I'll jump in.
Thank you,
All
Christy.
right, so I'm just talking about this graph, so, or this would be something maybe that I wanted my students to talk about. You know, if we compare the not adjacent to water and the adjacent to water in the woodland, right? If I'm looking at this graph properly, I'm looking at a woodland here. Oh, you guys can't see my mouse. Haha, I apologize. I was using my mouse like you could. All right, so if we're not adjacent to water, it looks like we have a lot of eggs compared to when we are adjacent to water. I'm noticing that.
I want to reiterate that this is only where you place the traps. This has nothing to do with eggs yet and nothing to do with adults.
Thank you, Becky, for clarifying. So
yeah,
but we were interested. A lot of us stuck things. We placed our traps in woodlands and the tree line. As a group of individuals, we thought, let's not do the grass. We placed our traps in the woods or near a tree line. Is that a better observation? But way more not adjacent to water. And that may have something to do with our access to water at these places, right? At these locations. You know, maybe schools don't have a ton of water sources nearby. I don't know. I'm just throwing ideas out. Is that better? Is that a thought?
I found it very helpful. Would anyone like to build on to what Christy shared?
Kind of looking at it, while there was not a lot of build on the parking lot cemetery, the other and the field grass were pretty much put near water all the time. Other was a perfect match, I think. And there was only 6 difference on the field grass to the actual adjacent to water.
So these pardon me, David, thanks.
Yeah, when we put them out in the fields and all that, the other areas, we were looking for the water more, I think. That'd be an observation.
Yeah, okay. So, Christy, I heard you add a couple important insights that made this data sort of come to life for me a little bit more, because you put it in terms of where we were selecting these to put these traps. The big thing you noticed was that we really picked out tree line sites and forest woodland sites, and that those weren't necessarily close to water, but that might be due to access. And David, you were just pointing out that the field grass sites, there's a little difference, you know, six observations, 6 cases are different, but these seem much more comparable in terms of adjacency to water versus not. Okay, great. So let's move on for now. So again, as Becky pointed out, this is just looking at where we place the traps, and that's maybe interesting for just beginning to get a grip on the data. But we might want to do something that actually dives more into what the questions related to 80s are about. So I just moved this down here. I could delete it, but I'm going to keep it because it might be useful to me just for getting some ideas later. So I have a new graph here, and anyone have a preference for looking at total adults versus total eggs, or a recommendation for which to look at? Again, just exploring the data at this point. I'll pick out the adults. So I can drag it down to the x-axis again, just to get a kind of, oh, we've already looked at this one. Okay. Actually, let's move it to the y-axis instead. So function interpretively the same plot, just different orientation to it. But it might be helpful if you talk with your students about the y-axis representing your dependent variable, the thing you're trying to explore, understand. So just it's a convention, but sometimes conventions can be handy just because they communicate a certain meaning about what that variable is doing here. So we put that on the y-axis, and maybe we can calculate a statistic, not just the count, but maybe the average. And we can hover over that line and see that on average across all 576 cases, there's this value here. Could somebody interpret this value? I mean, not knowing much about CODAP or what necessarily this is doing behind the scenes here. Sorry, I can't see it again. I'll zoom in a little bit. But there's a blue line on this kind of plot of the distribution of adults, and it's got a value here. I'm wondering if somebody would be willing to dive in and kind of tell us what this means in the context of our data, or try to. Guesses are okay.
In the chat, Paula mentions that it's the average.
Paula, can you say a little bit more? Average of what?
No, I can't say anymore. Just it's linear. I can't really see the graph very well.
I'm really sorry.
No, it's okay. I think part of it might be my computer. Everything is really super small.
Shoot, I'm sorry. That's not.
No, that's okay. Just are they like, what's the title of this graph?
Yeah, good. Look for some context here. It's not super informative, but it tells us just cases at the top, and then our y-axis is total adults.
If you remember, cases are egg papers.
Okay, so that's just the average adults that hatched on the egg papers.
Anyone agree? I see Stephanie nodding ahead. Any others agree with Paula's interpretation?
Sounds like it.
Okay, David, I hear agreement as well. So cool. Okay, that seems like a helpful interpretation. So is that higher or lower than what you would expect? Just like completely, just like not, maybe it's hard to say just on average, but how does that number line up with what you'd expect in terms of total number of adults?
Lower.
A little lower?
The nice thing on my side is it's very similar to what Corey got and shared with you.
Okay, so so this is maybe getting more helpful to us. Sorry, I know this is hard to see, so I sincerely apologize for that difficulty. I'm going to make this as big as I can, actually, because we don't need to look at the data so much right now. I wonder if I can make the font bigger on these two. Point size. That makes the points bigger. I bet there's a way to make the...
Viewer can go to their view options up there where it says you are viewing your Josh's screen. If you click on view options, your ratio, you can do your zoom ratio.
So maybe dedicate more room, less room to the camera and more to the shared screen, Julie?
Oh, I see where you're
well,
talking.
I'm just saying that, yeah, they won't see anybody's pictures. You can just get your whole screen with your graph just by whatever ratio you want to see your screen with. So if you go to view options.
I got it.
Click on view option, click on zoom ratio, and then you can fit it to your window.
Thank you. Anyone have any issues with that? And Julie's now the official expert on making Zoom work here, so Julie can field your question. Thank you, Julie. Okay, so just one thing before we move on to the next part of this, one thing that can be really important is not only knowing what the average is, but also what the spread is. The standard deviation is a really helpful statistic for doing that. And this tells us that one standard deviation is 44 eggs. So it's much larger than the mean. And so even though our average is 14 adults hatched per egg paper, there's a lot of variability. And the plot shows this too. I mean, we have everything from hundreds and even more than 1,000 adults, sorry, down to many, many, many papers with 0 adults at all. So there's a lot of variation too. This isn't like a really narrow band where papers have between 10 and 20 adults per paper. That you could imagine data that looks like that, but that's not our data. Another thing that you might be interested in doing is looking back at land cover once more. And so I'm going to find that land cover variable again. And I'm going to drag it down to the x-axis. And here we can see something like the average per type of land cover. So I'm going to hover over this line here. Can anyone see that? And if so, can you interpret what that means there? There's my cursor's over a blue line in the figure.
So is it the average number of adults that hatched in a field grass area?
Anyone agree or disagree with Crystal? Thank you, Crystal.
Just because I hate when my students do this and don't say anything when you ask a question. That's what I was thinking is what she was saying, that it would be that if that's what the blue lines are representing.
Okay, great. Thank you, David. And thank you, Crystal, too. And so we can also drag these to reorder them, sort of like you do with the plot of land cover by just the number of papers we had. And so is anyone willing to take a stab at sort of interpreting this graph here, just kind of overall, just a big takeaway, kind of like we did for the first figure?
Well, it looks like, and I hate doing this again, I hate doing one talking, but it looks like the field grasses were doing better for getting adults born than even the forest, even though we did more in the forest than we did in the field grass.
So what I heard you say, David, was that even though there were more papers and therefore more cases in the forest and the tree line, the number of adults seems to be higher for papers placed in field grass. I see a few nodding heads here. And so where, and can someone speak to maybe where, so that's speaking well to the prominence here of adults, but how about where adults are not present? Kind of the other part of this figure.
I don't like cemeteries very well, where the dead are at.
They don't. Yeah, it seems like, in fact, it doesn't look like there's any adults at all. Not a single one hatched in a cemetery.
Yeah, but that gets into the other thing that we only put, it looks like there was only one trap put in the cemetery. So it just meant the one trap wasn't getting anything. So I don't know, because there was not an even distribution of traps across the board. So you couldn't get an even balance.
Okay, so David's raising the point, maybe we don't have enough data to say for sure. So one other thing that you might find helpful is you can go to show parent visibility toggles. And this is kind of neat in that it lets you pick out data just from a specific teacher. So this is just from Humphrey. And we can see for the sites associated with Humphrey, we had traps in forest, woodlands, and tree cover. And the same kind of pattern seems to holds for the overall data. There's a mean of 22.8 adults for the egg papers in sites that are associated with tree line land cover, and only 11.8 adults for those around forest woodland sites. And so this might be just kind of part of the puzzle. You might want to make this more complicated. You can drag a third variable into the main part of the plot here to color the points by a third variable. So we can see that tree line seems to be sort of also associated with, in this case, greater adjacency to water. So there might be sort of a complex story that you can sort of start to begin to figure out about what's going on in the sites associated with Humphrey across these two variables in terms of the number of adults. Now, this is real world analysis, and therefore it's really complex. Do we want to look at eggs, not just adults? Do we want to consider other factors such as the week or the elevation? Do we want to compare sites across different traps? We have a trap identifier variable as well. So there's a lot of ways your students could take this. And that's sort of where I wanted to leave us for this afternoon, for anyone that's interested in CODAP and using it more, is kind of thinking of the driving question being something like, why are there more adult mosquitoes in some places than in others? Why are there more in some places than others? And there's a lot of things that you are probably have already considered. I know you have. But things like, what kind of questions did you ask, and how did those motivate where you placed these traps in these egg papers? What do you or your students think might matter based on your understanding of the school and where you've seen mosquitoes and your intuition, just knowing this area well, where you place the traps? And then another question that's a little bit different is, how will you know, and what counts as sort of evidence in the context of this investigation? So what role do graphs play? What role, graphs like this, what role do summary statistics play, such as the mean? And what role do measures of sort of variation or uncertainty also play? So this, again, is the standard deviation, which tells us that even though the mean is higher for sites in the tree line, it complicates our otherwise kind of clean story a little bit, in that the standard deviation, one standard deviation, is 36.7 adults. So there's also more spread. Well, they're pretty close actually, 34.9 and 36.7. So maybe that's just because this bar is higher. So okay, the spread's pretty similar here. But another thing that sort of relates to, David, your comment about maybe there not being enough data, is maybe the mean is higher, but the differences between individual egg papers are all over the place. And so it's not really a systematic mean difference, that there's still a lot of variation. And just intuitively, you just might be unsure. You might feel like you need more data or more evidence to be convinced. And so thinking about what you would need to be convinced and what your students would need to be convinced that there really is something going on here, that there really is a difference. What counts as sort of standards of evidence? And then how do you deal with messy data and messiness? There's almost always going to be outliers, messy data, confusing parts, data collection errors. How do you account for those in your analysis to still come to some kind of meaningful takeaway? And so I guess the last question I'll pose is, how can you plan for these kinds of things in a lesson planning sequence? What would be a reasonable goal? And this is something I'd really love to learn from you, is how could you set this up so students could create a graph that they could share? They can take a picture here and export it really easily just to a local file. They could really quickly and easily maybe create a figure that summarizes their data, but it's still a lot of work to get here. And I've used CODAP for years now, and it's not easy to do this. So I'd be really curious about what kinds of things you'd want to do in a lesson to kind of get students to, not this chart, this is not necessarily the chart you'd want to make. There's a lot of things to consider, and there's a lot of variables here in this code book. That's all. What questions before we move on to the next tutorial do you have? Yeah,
before you move on, can you because I don't think this was Diane's question, so it's not really kind of interesting. I don't see a difference. Can you maybe put her question with it? I think it was elevation. So instead of having on the x-axis the forest and woodland land cover, could you put down their elevation?
All right, so the elevation column is the last one in the data set here. So scroll all the way to the right.
There's elevation.
Whoa.
Awesome, right? And then if we can do, so one of the cool things I liked about CODAP when I was playing with it is you can have total adults on the y-axis, which is great. Can you also put eggs on there too for us?
I don't know if you can have two y variables. Can you?
You can.
What?
I know. Yeah. Yeah, I think you can put them on the other y-axis too. I played way too much with CODAP. The undergraduate students in one of my classes was like, this is fabulous, and I agree. But so you can see this kind of ratio or comparison of eggs with adults through your question that you all asked. and then potentially looking at the mean there too.
Okay, I think it got confusing with the third variable. So here, it's still a complex figure, but I can see that those colored kind of looks like dark green are associated with this y-axis of total eggs, and those that are, yeah, this
Kind
is
of an
highly
orangey.
complex. Yeah.
Like if you're colorblind, this could be very difficult.
Yeah.
I'm being greedy. Could you actually post mine on there, because I had a major elevation difference on the traps. They're just two basic elevations.
Yeah, let's look at yours, David.
There, so he's got his 3 elevations there, and
Do you
each one of those dots
yeah.
is associated with an egg paper. So there's one egg paper at around a little less than 700 elevation that had a little less than 80 eggs, and then few adults down there because it's a different color.
Wow. So we have quite a range of elevations from, it looks like 681 feet up to more than 1,600.
Yeah.
It does seem that, okay, that makes sense. There's more papers with total adults of being 0, where almost every paper got, it looks like, some eggs, but not everyone had adults hatch. Okay, great. Thanks, Becky. Okay, now I'm interested in calendar week real quick. We need some
So I
kind
think
of.
what's awesome about CODAP is you can do this. You can just play really quickly with the data set and just let your students have fun, ask questions. Maybe they'll come up with something that we didn't even think about looking at. I'll probably say they will because they're very smart.
Okay, again, my kind of conclusion here is how can we plan for this in a lesson planning sequence, even if it's something small? A benefit of CODAP, putting on my salesperson hat here, is whenever you create, you can even take this same link that is shared here, right here. You can share this with students. This would be all the data, so you might want to create one just with your class's data. To do that, you just go share, click link to shared view, enable sharing, and then you copy and paste this link into an email or into Google Classroom, or however you want to share it with students, so they can see exactly what you're seeing at the time you share it. So it's pretty easy to set up, but then still, how do you get students to create something, some kind of figure with it? Something I'd really like to learn. Okay, I'll pause one last time for any questions or reactions or thoughts.
I just think this is really awesome, and I love the fact that this is a resource that we have and we can use. I'm thinking like Becky, and I'm thinking, how can I use this with my undergrads?
Cool, thanks, Michael. I love that you have to think about the plot. Like, you can't just choose from different figures that Excel recommends, but you have to think, what is my X representing, or what do these points represent? And it can really spark some good discussions. Yeah, with undergraduates, I use it with my my science teaching methods class students too. Okay, so this afternoon, it's going to be more collaborative, and we'll talk about some ways that you can plan lessons around this. Maybe one lesson or maybe more. Thanks. And I do think, just to kind of feed into the next section, what this is really complementary with is ArcGIS, which has the capacity to plot spatial data. And so that's not something that CODAP is really set up for. You can create simple maps, but I tried, and it's really quite limited compared to the kind of this kind of data and this kind of graph. So I think it's kind of a great combination that we have here for you to choose from in terms of how you analyze the data. So yeah, that's it for me. Thanks. Thanks for getting us squared away with the size of the screen too. Sorry about that.